Welcome to Science Lab with Mrs. Keener. Hi everyone. In the last Science Lab, we learned how to use Morse code. That's just one of many different kinds of codes that people use to communicate. If you're interested in learning more about different kinds of codes, I encourage you to find a book about codes. Some of them are more complicated. Many of them are very interesting. Today, we'll learn the code that computers use to communicate. You're going to need 5 small pieces of thin cardboard. You can take 3 index cards and cut them in half and save 5 of those halves. If you don't have index cards, you can use a thin sheet of cardboard from a box of crackers, a box of cereal, something like that. Cut out 5 pieces that are around the size of your hand. If you don't have thin cardboard, use the thickest paper you can find. Spread your cards out all in a row. On your first card, take a pencil and make 1 dot. Don't draw it super dark though. We want to make sure that you cannot see it through from the other side. So make sure you can't see it. That's our first card on the right. In the next card, draw 2 dots. Again, draw them pretty light so they don't show through. Want to make a guess how many dots go on the third card? It's not 3. We need to put 4 dots on our next card. There's a pattern here, maybe not what you thought it was. On the next card, make 8 dots. Can you see the pattern now? You don't have to draw your dots in the same kind of grid that I do. You can draw them any way you want as long as you have 8 dots. Want to make a guess how many dots go on the next card? If you guessed 16, you're correct. Now turn all your cards face down and keep them in the same order. So the 16 dot card is the first one on the left. Now try to remember which one goes where and show me 1 dot. Just turn over the card on the far right. If you want to see 2 dots, you just turn over the card that's the second one from the right. Now let's make 3 dots. Turn over the 1 card and the 2 card. That's how you make 3 dots face up. If you want to see 4 dots, you turn over the 4 dot card, the middle one. To show 5 dots, you turn over that middle one again and the 1 dot card. If you want to make 6, you turn over the one with 4 and the one with 2. To see 7 dots, turn over the 4, the 2, and the 1. How do we make 8? Just turn over the 8 dot card. So, see the pattern here? We can use these cards to make all the numbers, well, up to a certain point. At some point, we're going to run out of dots. Have you figured out what the largest number of dots is? How many dots would we see if we turned all the cards face up? We can make all the numbers up to that number just by turning certain cards face up. Now, we're going to make the code. What if I told you your code is yes, no, 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 no? That means the first card, you turn it right side up, and the other cards, you leave them face down. What number do you get? you get 16. So yes, no, 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 no is the code for 16. What if I gave you the code no, no, yes, no, yes? Leave the first card face down, leave the second card face down, turn the third one face up, skip the fourth one, and turn the fifth one face up. No, no, yes, no, yes is the code for 5. So for every number that we can make, there's a code we can make. Now I'm going to give you some more challenges. Try to decode these challenges that I give you and tell me in Flipgrid what you get. So this is not just a fun thing to do with cards. This is also really important for every computer that we use. Computers can't understand anything complicated. They only understand if electricity is on or electricity is off in their circuit. When it's on, that can be called yes. When it's off, that can be called no. So if you give the computer a code like yes, no, 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 it can translate that. Each card has 2 positions, facing up, facing down. Yes, no. That's kind of like on or off for the electricity in the computer circuit. It only has 2 possible states. That's why we call this binary code. Bi, B-I, means 2. There are 2 possible states, yes or no. Computers can understand binary code. And that's very useful. Like I said at the beginning of this video, there are many different kinds of codes. Can you think of a different kind of code? Would you like to invent your own? You can try to invent your own code using these cards, or you could make up a different code using whatever ideas you have. If you can think of an idea for a different code, share it with us in Flipgrid. If you share a code in Flipgrid, make sure that your video turns out forward-facing so that we're not looking at it backwards. I look forward to seeing your videos in Flipgrid.